Okay, in chapter 8, 8.2, kernel and range. Okay, definition. If F map V, vector V onto vector W is a linear transformation, then a set of vector in V mapped into 0 by F is called the kernel of F with denotation KER bracket F. Okay, the set of all vector in W that are the image of at least one vector in V is called the range of F with denotation range bracket F. Okay, so by definition, if F is a linear transformation from vector V onto vector W is a linear transformation, then kernel F is a subspace of V. And second, a range F is subspace of W. Okay, in a matrix form, if F is a linear transformation from space N onto space N given by a multiplication of M times N matrix, then kernel F is a null space of A. And range F is a column space of A. Okay, example kernel. The kernel of a transformation is a vector that makes the transformation equal to the zero vector. So this is the linear transformation defined by a matrix of this form. So when this transformation is set to 0, so we solve the equation, the three equations. Okay, now from this equation, we form an augmented matrix like this. Okay, so this is a set of equations. So we form a matrix equation first by form an augmented matrix like this. The coefficient on the left side is this form and the right side is 0, 0. Okay, now find the RRE form of the matrix here. So once using ERO, we will get the RRE form in this matrix. So you need to use the ERO or number of steps, then you will get the RRE form in this matrix. And then we find the solution. So the solution x3 is 0. Here is x1 minus x2 is 0. Since we have two equation and three variables, so we need to set one variable as another variable. So let's set x2 be t and x1 be t, because x1 equal x2. From this equation we have x1 equal x2, therefore when x2 is t, x1 is also t. So we have solution 0, t, x1 is 0, x1 is t, x2 is t, and x3 is 0. So the solution will be like this. Then we have the kernel of S is the subspace of the solution here. So this is the basis of the subspace. Okay, so the kernel of S is given by this basis. So kernel S is given by this vector.